Hi PU2 aspirants, so our final exams are very close and it's time to gear up your preparation to study very effectively and strategically, right? So yes, in this video I'll be discussing the passing package for chemistry PU2 final exams. So in this video I'll be giving you all the important chapters, important questions that you need to revise, okay? And I'll also be telling you the chapters that you can skip so that you can focus on less and score more, okay? So I'll be also giving you most important questions, derivations, numerical formulas, everything in this one video. So if you watch this one video, you can easily target 45 plus in your chemistry examination, okay? So without any delay, let's get started, and I want all of you to sit with a notebook and a pen where you will be writing all the important questions, numerical formulas, everything, okay? So let's get started with the chapters that we have in our syllabus. The chapters list, okay? So I'll be telling you like these are the chapters which you should be doing, okay? But I told you I selected this chapter based on their weightage, based on the easy or the difficulty level of the chapters. So which chapters I have selected from physical chemistry is solutions and kinetics. Then from DNF block, from inorganic chemistry, I have given you both the chapters, okay? But you can do any one, okay? But I feel both the chapters are somehow connected and easy to score, so I have given you both. And in organic chemistry, you can do these three chapters, okay? So haloalkanes and haloarenes, alcohols, phenols, aldehydes, ketones and carboxylic acid. So total 1, 2, 3, 4, 5, 6 chapters you have to do. Now apart from this, these are the chapters that I can say not mandatory, but yes, if you find any of these chapters easy, like for example I can say these two chapters are very small, right? So if you have time, you can finish these two chapters also. So my recommendation is you have to do these 6 chapters, and then if you have time, you can go for these chapters. Or I can also say like this, if you want to skip this one particular chapter, okay, aldehydes, ketones and carboxylic acid, because it is a very lengthy chapter, you can skip this one and you can do these two instead of this one. Okay, that is also option is available. So you have to do 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6. Okay, so I can say almost doing this chapter is equal to doing these two chapters, okay? So anyway, you can manage. And electrochemistry, also I'll be telling you some very repeated questions. So if you can do this question, only that few questions from electrochemistry, then overall your preparation will be very solid for the examination, okay? So yes, now we will move forward to the first chapter, that is solutions. So from solutions you will be getting 2 marker questions, 3 marker questions and 3 marker numericals, right? 3 types of questions will be asked. What all things will be asked? You will get 2 marker theory, 3 marker theory and 3 marker numerical. Okay, so I'll be discussing what all questions can be asked from here. So just do these questions and I'll give you some topics also that you should be studying, and definitely you will be able to score marks in this. Okay, let us see the first question, that is your Henry's law and its mathematical form, and what is the significance of KH value. This is very important question. You should be knowing the statement, the mathematical form and the significance. So what does Henry's law tell you? Henry's law tells that the solubility of a gas depends on the pressure of the gas above the liquid. Okay, that is done. Next, what is the mathematical form? P is equal to KH into X. So here you should mention the terms, okay? This is important here. So what is P? P is partial pressure of gas. What is KH? It is Henry's constant, okay? What is X? That is mole fraction of the gas. Clear? Next, significance of KH, higher the KH, lower is the solubility. Okay. Now let us see the next question. Okay, so before moving to the next questions, I want to inform you something very important. So we all know that once the final PU2 exams are over, our KCET exam will be approaching. So to help you with your preparation, to boost your preparation, we are running two important programs. One is our Lakshya KCET crash course and another one is Abhyas KCET test series. Okay, so Lakshya KCET crash course, it is an offline crash course that is conducted in different Diksha Vedantu centers of Bangalore. Okay, so you can come here and join it. We have both residential and day scholar program, so you can come here and join, and in that you will be getting daily practice test, one-on-one doubt sessions, full syllabus coverage, PYQs focus and guided study hours. So in your study hours, teachers will be available to clear your doubts. Okay, that is one program available. Now in case you are not able to shift to Bangalore for this crash course, you want to prepare from your home, you just need help with the test series and all, so we also have a program that is Abhyas KCET test series. So in this you will be getting 35 mock tests, which includes part test and full length test. In this 35 there is 4 tests absolutely free for all of you and 31 paid tests. Okay, and then you will be getting video solutions and analysis, one shot revision videos and chapter wise insight for the last 5 years of previous year questions, which like from a particular chapter from the last 5 years, which topic questions have been asked. Okay, next the offer price for this Abhyas KCET 2025 test series is 1499. Okay, so here one extra thing is there. If you just like the test series price is actually 1498, but if you pay 1 rupees extra, that is 1499, you will also get our PU2 success blueprint test series. Okay, so that is coming at 1 rupees now, but provided you are purchasing this test series as well. Okay, now if you have any doubt regarding anything, you can call us to our number. Okay, all the things you can ask, clarify, and then you can purchase, and the link of this programs will be there in the description section of this video, so you can go there, click on the link, visit the site and then enroll yourself. Okay, fine. Now we will move to question number 2. The second question from solution is, state the Raoult's law and give its mathematical form. Vapor, what is vapor pressure? Then vapor pressure of CHCl3 and CH2Cl2 are 200 to 415 mmHg, which is more volatile. So generally we have, this is the most important question, Raoult's law. So Raoult's law, you know, it states that in a solution of two volatile liquid, the vapor pressure or the partial vapor pressure of each component is directly proportional to its mole fraction. Okay, so P is equal to P naught A XA. So I can just write like this. Sorry, one second. Yes, you can write this one like PA is equal to P naught A XA, where P is equal to pressure of the solution, P naught A is the pressure of pure solvent, and XA is the mole fraction of the gas. Next we have here question, what is vapor pressure? So let me explain what is vapor pressure, or let me give you the answer for this one. So vapor pressure, okay, vapor pressure is the pressure exerted by the liquid, pressure exerted by the vapor, pressure exerted on the liquid by the vapor present above it when the system is in equilibrium. Okay, this is done. Next, vapor pressures of CHCl3 and CH2Cl2 are given to you, which is more volatile. Now see, if the vapor pressure is high, that means more amount of the solvent has vaporized, right? So if more amount of solvent has vaporized, that means it is more volatile. So I can say that the one which is having higher vapor pressure, that is 415 CH2Cl2. So that will be your what? I can say more volatile. Okay. Next, we'll go to question number 3 here. Write the expression to relate the cryoscopic constant and the change in enthalpy of fusion. Explain the terms involved in it. Okay, so this is a good question. So we have here Kf is equal to molar mass, okay, into R into T by 1000 into delta H of fusion. Okay, so what are the terms here? So I can just write down this as M into mr Tf square, okay, divided by 1000 into delta H of fusion. So what is M here? M you can write molar mass, okay, R is gas constant, or you can write universal gas constant, okay. Next, Tf is freezing point of the solvent, freezing point of pure solvent, okay. Next I have delta H fusion, that is your enthalpy of fusion. Similarly, question can be also asked for ebullioscopic constant, that is your Kb, right? So here I'll put T naught F because it is for pure solvent, and I can write for Kb, okay. The similar formula can also be asked for your Kb, so I'll explain that as well. One second, yes. So Kb is equal to, you have molar mass into R into T naught B square, okay, divided by 1000 into delta H of not fusion, here it will be vaporization, okay. So this will be vaporization. So all other terms are same. What is T naught B? T naught B is the boiling point of pure solvent, okay. And what is delta H of vaporization? Enthalpy of vaporization. Okay, fine. Now we'll move to next question. Okay, just a minute. Yes, draw a graph to show the variation of vapor pressure of solvent and solution with respect to temperature. So this question was there in model paper, very important, I think model paper 2. So you have to draw a graph related to the vapor pressure and solvent with respect to temperature. So if you see, if you increase the temperature, vaporization will increase, so vapor pressure will increase, right? So we have a graph like this, okay. So the graph for this one will be like this. On this side you have vapor pressure, okay, and on this side you have temperature. So as you increase the temperature, the vapor pressure will increase. Now the vapor pressure of, if this one is the vapor pressure of solvent, sorry, this is the vapor pressure of the solvent, then what will happen? You know that at a particular temperature, the vapor pressure of the solution will be less than that of the solvent. So for solution it will be less than the solvent, okay, clear, getting? So here we can draw a point, the boiling point, where the vapor pressure of the atmosphere meets the vapor pressure of the solvent or solution. So this will be your boiling point for the solvent, and this will be the boiling point of the solution. So you don't have to show that, but this has to be the graph here, okay. Next, question number 5. Okay, this is repeated, okay. Give the difference between ideal and non-ideal solution. Very simple, you can just mention 2 points. It can be asked in the 3-marker question also, 2-marker question also. These 4 points I have given you. Apart from this, one very important point is your examples, okay. So ideal solution you can write down, for example, benzene and toluene, right, benzene plus toluene. You can also write N-hexane and N-heptane, okay. Next, in case of non-ideal solutions, what example we can give? Ethanol, okay, ethanol and water. you can give the example of what is it, acetone and ethanol. Okay, so any non ideal solution example you can give here. Next, similarly you will have difference for two types of non-ideal solution, that is positive deviation and negative deviation. Here are the points that you can mention. The interactions in positive deviation is very weak, interactions in negative deviation is strong. Here all the terms will come positive. Okay, so I will remove this point. Okay, just a minute. Yeah, so if I remove this point, okay, it is not looking like removing, it's looking like I'm highlighting, right? Can I, yes, I can remove this point. Okay, so apart, in place of that I will give you one more point. Okay, so what we can write here, one more point, that is, here you can write down, yes, here you can write down delta V mix is greater than 0, and here delta V mix is less than 0. Okay, so 1, 2, 3, 4 and examples here 5 points are there. Okay, you can write any 2 to 3 points. Next, minimum and maximum boiling azeotrope, it shows negative deviation. The maximum boiling azeotrope shows negative deviation, this one shows positive deviation. Here they boil at a temperature higher than the boiling point of individual components. Here they boil at a temperature lower than the boiling point of the individual components. Examples here, nitric acid and water, and here you have ethanol and water. Percentage wise you should remember. Okay. Next, what is reverse osmosis and give its application? This is also a very important question. So first of all, what is reverse osmosis? When a pressure more than the osmotic pressure is applied on a concentrated solution, solvent flows from the concentrated solution to dilute solution through a semi-permeable membrane. This process is known as reverse osmosis. Next, what I have, its application. So it is used in the desalination of water. So if you see, I have given you a mixed question. If it is simply asked what is the application, you can just write one word, that is desalination of water. Now if the question is like this, explain how reverse osmosis helps in desalination of water, then you have to write this one and draw this diagram. That will carry again 2 marks. So I have given you everything in this one question. So what is reverse osmosis is used in the desalination of water when pressure more than the osmotic pressure, that is 30 atm, is applied to the sea water. Pure water is squeezed out of the sea water through the semi-permeable membrane. Now what is the semi-permeable membrane used here? That is your cellulose acetate. You have to remember this, and this diagram you can see, this side salt water, fresh water, you are giving pressure more than the osmotic pressure. So water will flow to from this side and you can get clear water on this side. Okay, so that you can do. Next we have, these are the 3 medical terms that you should be remembering. What is bends, what is anoxia, and what is edema. So see, bends is what, when do we suffer from bends? Okay, just a minute. Okay, I think I have added a wrong answer here. Okay, so this is not required. I'll just explain here. Okay, this is not required. This is from the previous question. What is bends? Bends is caused when more amount of nitrogen is dissolved in one second. Okay, so the first one, that is bends. Where it is found? It is found in scuba divers, right? That's the first thing. Why it is caused? When more nitrogen is dissolved in blood. Okay, so when the so I am just explaining you, when the scuba diver goes deep down the ocean, more amount of nitrogen get dissolved in the blood. When the scuba diver comes to the surface, because of the decrease in pressure, the solubility decreases. So what happens? The nitrogen bubbles come out of the blood in the form of in the form of bubbles, which can block your arteries and veins. This causes a medical pain called as bends. Okay, so when more nitrogen is dissolved in the blood, so when the scuba diver, so that I have explained, you can write down in your own words. Okay, next, What happens in anoxia? It is due to less solubility of oxygen in blood at high altitude. Okay. Next, what is edema? Edema is water retention in cells. Okay, clear? Okay, now coming to next one. Yes, why the vapor pressure of the solvent decreases on addition of a non-volatile solute. So this is a very expected question in the 3-marker question. So what happens when you dissolve any solute, the surface area, that was, suppose when there was no solute, all the surface molecules were solvent molecules. Now when you dissolve some amount of solute, the sum of the surface molecules are occupied by the non-volatile solutes. So these solutes will not evaporate, only a few amount of solvent molecules will evaporate. So that is why the vapor pressure will decrease. So how can I write that? Yes, see, in a pure liquid, the entire surface is occupied by the molecules of the liquid. If a non-volatile solute is added to a solvent to give a solution, the vapor pressure of the solution is solely from the solvent alone. Now in the solution, the surface has both the solute and the solvent molecules, thereby the fraction of the surface covered by the solvent molecules get reduced, and consequently the number of solvent molecules escaping from the surface is correspondingly reduced, thus the vapor pressure is also reduced. Okay. Next, why is the freezing point decreases on adding a solute, why the boiling point increases on adding a solute? These two are also very important question. So here if you remember, so when you add a solution will freeze when its vapor pressure equals the vapor pressure of the pure solid solvent. Okay, so I'll draw a graph to and make you understand this one. See, okay, so you have how can I do? So this is solvent, okay, in liquid form. Okay, now after it has a, and this is solvent, okay, in solid form. When this vapor pressure of the solvent in solid form and the vapor pressure of the solvent in liquid form meet, at that point we get the freezing point. Okay, T naught F. Now when you add a solute, what happens? The vapor pressure of the solvent will decrease, right? This is the vapor pressure of the solution now. Now when this one will meet the vapor pressure of the solvent, at this point you will get the freezing point. So the freezing point is less than the freezing point of the solution. Okay, so that is the thing, that is why the freezing point decreases. Now what happens in elevation in boiling point? The same thing. See, boiling point I have just discussed you. We have here vapor pressure, we have here temperature. This is the atmospheric vapor pressure. When the vapor pressure of the solvent meets the vapor pressure of the atmosphere, that is your atmospheric pressure, at that temperature we get the boiling point. So I'll draw it in a better way, okay, so that you can understand. See, suppose this is there, okay, this is the vapor pressure and this is the boiling point or temperature. So this is your atmospheric pressure. When the vapor pressure of the solvent matches the vapor pressure of the atmosphere, at that time we get a temperature, or what is the temperature at that point? That is called as your boiling point, T naught B. Now when the vapor pressure of the solute, this is solvent. Now when you add solute, the vapor pressure of this will decrease. So when this vapor pressure meets here, so we get a elevation in boiling point. Okay, so this is for solution. So that is what you have to explain here. I have given the answer, you can read it. Next, just a minute, 10, 11, 12, okay. Okay, now we will go to some numerical questions. 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.4 Kelvin. The freezing point depression constant of benzene is given. Molar mass of the solute. So you will be getting questions from the colligative properties formula. So first question, if you can see here, we have depression in freezing point. So what is the depression in freezing point? Delta TF is equal to Kf into molality, given mass of the solute by molar mass of the solute into 1000 by mass of the solvent. Okay. So now if I just substitute, I have 1 gram. So let me write down the values. W2 is 1 gram. Okay. 50 gram of benzene. W1 is 50 gram. Okay. Next we have delta TF is equal to 0.4. Okay. And we have now KF. KF is 5.12. Okay. I have to find the molar mass of the solute. So I have here 0.4 is equal to Kf is 5.12, W2 is 1, M2 I have to calculate into 1000 by W1 is 50. So if I solve this and find the value of M2, I will be getting 256 gram per mole. You can check the calculation. Next we will have from boiling point, similar question. Boiling point of benzene is given 353. So that is T naught B is given 353.23 Kelvin. Okay. Next what is there? 1.8 gram of W2, that is the mass of the solute, 1.8 gram. Non-volatile solute, non-ionizable, was dissolved in 90 gram of the solvent. 90 gram of solvent, W1 is given. The boiling point raised to 354.11. So TB is now equal to 354.11 Kelvin. Calculate the molar mass of the solute and we have here Kb value, that is 2.53 Kelvin kilogram mole inverse. Okay, fine. Now let me calculate here delta TB is equal to T naught P minus TB is equal to Kb into M. What is M here? W2 by M2 into 1000, right, by W1. So let me substitute here. What is T naught B? Sorry, here elevation in boiling point takes place, right? The boiling point of the solution will be more. So I can put here exactly the value 354.11 minus 353.23 is equal to Kb 2.53, W2 1.8, M2 I have to find out, 1000 by W1 is 90. So if I solve this, I will calculate the value of M2 as 57.27 gram per mole. Okay. Next, calculate the osmotic pressure in pascals excreted by a solution. I think this is exerted by a solution prepared by dissolving 1 gram of polymer. What is the mass of the solute? 1 gram. 1 gram of a polymer of molar mass. What is the molar mass? 185,000. Okay. In 450 ml of water. 450 ml. Volume is 450 ml. Temperature is 370 degrees Celsius. So what is the temperature in Kelvin? 273 if I add 643, right? So temperature is 643 Kelvin. Okay. So now if I erase this one, so what I will get? Pi is equal to C into R into T, where C is molarity. So I can write here W2 by M2 into 1000 by volume, okay, then R into T, right. So now I will put with units so that you don't get any confusion here. See, W2 is 1 gram, right, M2 is what? 185,000, right, 185,000. Molar mass unit is gram per mole, right. So I can write gram mole inverse into 1000, right. Volume is in, it was in milliliter, but I divided by 1000, so it become liter now. How much it is? 450. So this whole unit is in terms of liter. Okay. Sorry, here it is, liter is in denominator. Okay. Next what happened? Into R value is 0.083 liter ATM mole inverse Kelvin inverse. Next, what is the temperature value? 643 Kelvin. Okay. So now what I can do, I can just crisscross, see gram cancelled, mole inverse cancelled, liter cancelled, then I have Kelvin cancelled. So whatever I will get, the answer will be in some ATM, okay, but you have to find in Pascal. You know 1 ATM is 10 to the power of 5 Pascal. So whatever answer I get, this one into 10 to the power of 5 if I do, I will get the answer in Pascal. So if I solve this, I will be getting around 30.9 Pascal. So you can check the calculation here. Next we will go to a question on your Raoult's law. I think vapor pressure of the benzene is 200 mm of Hg. Vapor pressure of benzene, okay, is 200 mm Hg. Next, when 2 gram of a non-volatile solute is dissolved in 78 gram of benzene, we have 2 gram of non-volatile solute. W2 is 2 gram. W1 is how much? 78 gram of benzene. Okay. Benzene has the vapor pressure of 195 mm of Hg. So at P is equal to now 195 mm Hg. Okay. Calculate the molar mass of the solute. Molar mass of benzene is already given. So this is from your relative lowering of vapor pressure, and in relative lowering of vapor pressure we have this formula, delta P by P naught, that is P naught minus P by P naught is equal to XB, that is equal to NB by, generally the formula is NB plus NA, but in this type of questions we can ignore this NB and we can just write NB by NA. Okay. So let me write down the values here now. So P naught I have, P I have, P naught I have, XB, for that I need to calculate NB. So NB will be given mass by molar mass. So 2 gram by the molar mass, which I have to find out, and NA given mass by molar mass, so 78, the molar mass is also 78, so it is 1. Okay. So now let me substitute here. So what is the value of P naught? 200 minus P is here 195 by 200, okay, is equal to NB. What is the value of NB here? 2 by m, okay, divided by 1. Now if you solve this, you can calculate the molar mass, which is 80 gram per mole. Okay. So this is easy calculation. So it is like 5 by 200 is equal to 2 by m. So m will be equal to 2 into 200 divided by 5. Okay. So it is 80 gram per mole. Okay. So this is the thing that you have to do in this particular formula. Next, here I want to tell you, before moving to the next chapter, something that is Vant factor. Okay. So you can also study about, so if you first you complete these many topics, after that if you have time, go for Vant factor. You can just learn what is Vant factor and how to calculate the Vant factor. So Vant factor is basically the number of ions produced after a solution is after a solute is dissolved. Like for example, if I have KCl, just explain here. If I have KCl, it will give me 2 ions, so I value will be 2. If I have MgCl2, here I will get 1 Mg and 2 Cl, so I value will be 3. So when these type of solutes are added, your colligative properties are also modified. So how the colligative properties are modified? So you will become like delta Tb is equal to now IKBm, delta Tf is equal to IKFm, then you have pi is equal to ICRT. So this I value will be included in all the formulas. Okay, now we will move to chemical kinetics. In chemical kinetics also you have the same 2 marker theory, 3 marker theory and 3 marker numerical. Okay, so in this 3 marker theory, it is always the derivation. Okay, derivation of 0th order, 1st order and 1st order in gas phase. These 3 derivations you have to prepare for this 3 marker question, 3 marker theory question. So let us quickly see what all questions we can do in 2 marker. So pseudo first order reaction, give one example. So what is the pseudo first order reaction? When one of the reactant is in excess, a second order reaction behaves as a first order reaction, right? So you have to write the definition and any one example, and this example you do not have to explain this much. What you have to write, you just have to mention this one line. line, acid hydrolysis of esters or methyl acetate, or you can write inversion of cane sugar. These two lines can itself help as an example. Next, what are the main criteria for effective collisions according to the collision theory? This is important question. So here you should write activation energy and proper orientation of the molecules. Next we have explain the effect of catalyst on the rate of a reaction. So a catalyst increases the rate of the reaction by reducing the activation energy, and this graph is very important where you have to show that this is the activation energy, one second, yes. So here you have to show, see, this is the activation energy when there is no catalyst used, and this is the activation energy when catalyst has been used. So the activation energy has actually decreased with the use of catalyst, and that is what the catalyst does. Next you have any 4 differences between molecularity and order. This can be asked as a 2-marker, 3-marker question. Mostly it will ask in a 2-marker question, so you can remember I have given you 6 points, you can remember any 2 points. Okay. Next we have yes, this question is important. It is now very like I can say a new question. It wasn't asked much in the previous years, but this year in model test papers, in your pre-board papers, these questions have been repeatedly asked. Write the Arrhenius equation and state the symbols used here. So you have Arrhenius equation, K is equal to A into e to the power of minus EA by RT, where K is rate constant, A is the frequency factor or Arrhenius factor, or we can also call it pre-exponential factor. Okay, pre-exponential factor. Then we have active E is the exponential term, EA is activation energy, R is universal gas constant, and T is temperature. Okay. Next, explain the Arrhenius theory of activated complex by using the potential energy level. Yes, this question is also very important. Okay, and also it is a new question. So Arrhenius theory, what does Arrhenius theory says? See, Arrhenius theory says that reactant, when it converts to product, it directly does not convert from reactant to product. It goes through a transition state. One intermediate is formed, and that intermediate is converted to product. Okay, so whenever a reactant is converting to product, it first goes through a transition state, and this transition state gets converted to product. Okay, so what is the Arrhenius theory saying you? According to Arrhenius, the reaction can take place only when the reactant molecules collide to form an unstable activated complex. Okay, one unstable activated complex is formed. It exists for a very short time and then breaks to form products. Now if you see example of HI, so question has been asked to explain Arrhenius theory by using an example, so you have to use this example. So if you have H2 plus I2, so they will not directly react to give you HI. First one intermediate like this is formed, a square shaped intermediate is formed. After that it dissociates to give you HI plus HI. Okay, so you can show that in the graph model also it can be asked. So you can see here H2 and I2 is there. Here one activated complex is formed. So what is this activated complex? This activated complex is this one. Right, this is the activated complex. Now this one breaks to give you 2HI. This is the energy of the reactant. From here to get converted to this activated energy, what is this energy required? Activation energy. This energy of this activated complex is threshold energy. The difference between these two is the energy of the reactants. Okay. Next, using energy distribution curves showing the temperature dependence of the rate of the reaction, explain the effect of temperature on the rate of the reaction. This graph is also very important. You have to draw the Boltzmann curve. You have to show at temperature T what was there, at temperature T plus 10 what is there. So here you can see increasing the temperature of the substance increases the fraction of the molecules which collides with energy greater than EA. So when you increase the temperature, you can see this fraction has actually increased, and this is the number of particles which is having energy more than the threshold energy. Okay, so that is why the rate of the reaction increases. Okay. Next, name the factors affecting the rate of a reaction, or on which factors does the rate of a reaction depends. Concentration, temperature, catalyst, these three are very easy to remember. I want all of you to remember these 3 points: concentration, temperature, catalyst. Apart from this, you have to remember other, if you want, nature of the reactants, presence of the light in case of photochemical reactions. Okay, now we'll go to 3 marker questions where you have to derivation. Derivation of zeroth order, first zeroth order reaction. So first you have to take the first statement, consider a zeroth reaction R gives you P. Now zeroth order reaction is proportional to zeroth power of the reactant. So after this you can directly write down this one. According to the rate law for zeroth order reaction, rate is proportional to R to the power of 0. Rate is equal to K into R to the power of 0. R to the power of 0 is 1. So rate is equal to K. Okay, this is the first thing. Next, where K is the rate constant or velocity constant. Next we also have rate is equal to minus dr by dt. Okay, now minus, this is one thing, rate is equal to minus dr by dt, rate is equal to K. Now you can equate these two. After that you have to do integration, you will get integration constant, you have to find the constant value, and finally you will get this equation. Okay. Next you have to derive an expression for the zeroth order half-life of a zeroth order reaction, right? So half-life of a zeroth order reaction, suppose this is our integrated equation. Half-life means what? The time in which this R became R naught by 2. So you have to substitute T is equal to T half, R is equal to R naught by 2, do the substitution, and then you will get here that T half is equal to R naught by 2K. So here the question is, derive an expression of half-life period of a zeroth order reaction, or show that for a zeroth order reaction the half-life period is directly proportional to the initial concentration. So by proving this one, that is T naught is equal to R naught by 2K, you can say that T naught is proportional to R naught. Okay, so here this shows that T half is proportional to R naught for a zeroth order reaction because 2K is constant. Next, derivation of first order, I think no need to explain, you all have studied many times, so this derivation you have to do. And then you have derivation for half-life also, same as zeroth order, just you have to substitute here T half, here you have to substitute R naught by 2, you will get 0.693 by K, and here there is no concentration term. So you can show that for a first order reaction, half-life is independent of the initial concentration. Next, yes, this is a tricky question. Okay, this is important question and can be asked, where you have to derive the integrated rate law equation for first order gas phase reaction. Okay, gas phase reaction. So I will show you this one. Suppose we have a reaction A gives B plus C. Okay, let the how will you write in the exam, I will tell you each and every step. Let us consider a reaction. Let us consider a reaction A gives B plus C. Okay. Next, let the initial pressure of A is equal to Pi. Okay. Let X amount of A reacted at or after time t. Okay, these three statements you have to give first. So what I will write, see, A gives B plus C. Okay, at t is equal to 0, what is the initial pressure? Pi. Here there will be no B, no C, so it is 0, 0, 0. At time is equal to t seconds, X amount has reacted, so it is Pi minus X, this is X, this is X. Next you can write, let Pt is the total pressure at time t. Okay, so I can write here Pt is equal to pressure of A, Pi minus X, pressure of B and pressure of C. So what I will get? Pi plus X. Now from here I can calculate X is equal to Pt minus Pi. Okay, now what I can write? Pressure of A. Okay, one second. Pressure of A at or after time t, that is equal to Pi minus X, that is equal to Pi minus X value is Pt minus Pi. Okay, so how much I will get this one? 2 Pi minus Pt. Okay, pressure of A after time t, I got this one. Now using integrated rate law equation, using integrated rate law equation for first order, what I will get? Kt is equal to 2.303 log of initial pressure of A. I'll write P naught A by Pa. Okay, here you can mention, okay, P naught A is the initial pressure of A, okay, and Pa is the pressure of A after time t. Okay, so just substitute the values here. 2.303 Kt is equal to 2.303 log initial pressure of A is Pi and final pressure of 2 Pi minus Pt. Okay, so that is what is the derivation here. Okay, next calculate the time in seconds for the okay, so now we will go to numerical questions. So calculate the time in seconds for the decomposition of nitrogen pentoxide which follows the first order kinetics when the concentration of N2O5 is dropped from 0.1 to 0.01. So this is already given, it is a first order reaction. You just have to equate the that is, you have to find what time, right? So I can write the equation like this: T equal to 2.303 by K log of, right, concentration of N2O5 initial concentration by final concentration. Okay, so what is there? 2.303. What is the value of K here? 6.22 into 10 to the power of minus 4. Okay, log of what is N2O5 concentration? 0.1, and this is 10 to the power of minus 2. So now if I solve this, it will become whatever, if you solve it, you will be getting around 3.7 into 10 to the power of 3 seconds. Okay, next we will see the graph of log K versus 1 by T for a reaction is linear with the intercept of 10 and slope of minus 5.1 into 10 to the power of 3. Calculate the frequency factor and the activation energy of the reaction. Okay, so I can draw this one. See the graph for Arrhenius equation, log K is equal to log A minus Ea by 2.303 R into 1 by T. Okay, so this is Y, this is X, this is M, and then this is C. Now if you see intercept of 10, intercept means this one, log A is equal to 10, it is given to you. Okay, next, and the slope is what? Ea by 2.303 R, Ea by 2.303 into R is 8.314. Okay, and that is your 5.1 into 10 to the power of 3. Okay, now calculate the frequency factor and the activation energy for the reaction. Okay, so frequency factor will be what? A will be equal to, take antilog on both sides, 10 to the power of 10, and Ea value will be equal to 5.1 into 10 to the power of 3 into 2.303 into 8.314. Okay, so now if you solve this, activation energy will get 97.65 kilojoules. Okay, that will be your answer after multiplying these all terms. Next we will see the rate constant of a reaction at 500 and 700 Kelvin are given to us. Calculate the activation energy. So this is from your Arrhenius equation, right? Log of K2 by K1 is equal to Ea by 2.303 R into T2 minus T1 by T1 into T2. So I will substitute everything. Log of what is K2 value? 0.07, K1 is 0.02, Ea by 2.303 into 8.314. T2 is what? 700 minus 500, okay, divided by 700 into 500. Right. So now if I solve this, activation energy I will be getting is around 18.228 kilojoule. Okay, so you have to do the calculation. Next we will go to a numerical like this where you have to find the order. So what is the order of the reaction with respect to A and B? So if you see, I can just write down that rate is equal to K into A to the power of X and B to the power of Y. Now if I want to find A, I'll keep B constant. So these two reactions I have kept B constant. What I have done, A concentration is double, you can see the rate is also double. So that means what? X is equal to 1. Okay. Now if you see for B what I have to do? I have to keep A constant. So if you see from point 1 to point 3, this is changing but this is not changing, right? That means what? There is no effect of concentration on the rate. So that means Y is equal to 0. So what is the, with respect to A it is 1, with respect to B it is 0. Okay. What is the rate law? Rate law will be equal to R into K into A. Okay. Then what is the rate constant? To calculate rate constant I have to do R by A, right? You can take any R here, like for example if I take 2 into 10 to the power of minus 3 and A constant I'll take 0.2, so I can get it here. This is 2 into 10 to the power of minus 1, it goes up 10 to the power of minus 2, rate constant. What is the half-life? So half-life formula is what? 0.693 by K minus 2, so that is 69.3. Right. So you can solve this question in this particular way. Next we'll see, in a chemical reaction the concentration of reactant A alone is increased by 2 times. Okay. Concentration of A alone is increased by 2 times, the rate is increased by 4 times. So I'll write, for example, this is there. Okay. Now if you increase the concentration of A by 2 times, the rate is increasing by 4 times. That means X must be 2. Okay, or it's a second order reaction. Next, if the concentration of both A and B is increased by 2 times, the rate is increased by 8 times. So now this 8 I can write like this, 4 into 2. So now when A is doubled, rate will become 4 times, right? That is because of A. But when B is doubled, rate is also becoming double. That means what? With respect to B it is first 1 degree. Okay. So that means I have got the answer. What is the order of reaction with respect to A and B? Okay. So with respect to A it is 2 and with respect to B it is 1. Clear? Next. Okay, so now we will go to the next question. So I am not telling, as I told you, only the important chapters passing package. So next question will go to coordination compounds. So here the first question, coordination compounds, where you will get questions. So you will get here, yes, you will get 2 marker theory questions and 3 marker theory questions. Okay, so let us see quickly the most expected questions. Explain with 2 examples each of the following: chelating ligand, homoleptic, heteroleptic, ambidentate. So these are the definition terms that you should be remembering. So chelating ligand is what? When more than one donor site binds simultaneously to form a ring-like structure. Example what we have here? We have example as EDTA. Yes, you can give example of EDTA and EN. Next we have homoleptic, where all the ligands are same, so you can give NiCO4 or you can write FeCO5. Heteroleptic, where we have different ligands, NiCl2H2O4, you can give CONH3 anything you can give. Next, what is there? Ambidentate ligand, which can have 2 donor atoms, but a molecule or an ion which has 2 donor atoms to form 2 coordinate bond with central metal atom. Okay, sorry, here is a small mistake. A molecule or an ion which has 2 donor atoms, but okay, I'll give you this definition by my own. Let me write down here, just a minute. Yes, what is ambidentate ligand? A ligand, okay, which has 2 donor sites, 2 donor atoms, but either of them bind to the metal. Means it has 2 sites, but any one will bind. Okay, so you can take example of Cn minus, NO2 minus. Okay, clear? Next, draw the isomers of PtCl2, En2 and COEn3 2+. So you should remember here En is a didentate ligand or bidentate ligand. So you can draw like this Pt. Okay, we'll do the transform. This is the transform. Okay, so this is one geometry where I have trans. Next, if I draw cis form, Pt Cl, I can draw like this En. Now if you do mirror images here, what I will get? Pt En Cl, and here I'll get En. Okay, so these are the three isomers. Now for COEn3, what I will have? You have like this. Now here if I draw the mirror image of this one, you will get, here I will get En, here I will get En, and here I will get En. Okay, so these are the geometries of these two isomers. Next, out of the following, the coordination entity which is optically active. So you know cis one is always optically active. So option A you will write. Draw the structures of it enantiomers. So oxalato is also a what I can say, this is also a ligand. Sorry, this is also a cis form. Okay, oxalato is also a bidentate ligand. So it will be like this. This is the cis form, and it will have mirror image like this. We have chromium and we have like this. Okay, so this is Cl, this is Cl, this is, okay, not En, you have to write oxalato. One second, yes, so this is oxalato and this is oxalato. Clear? Next question, we'll move postulates of Werner's theory. Okay, so you can mention what is primary valency, secondary valency, their definition. 2 points you should remember. Next, these type of isomerisms can be asked: ionization, linkage. So their definition and example you should be remembering. So in linkage isomerism we need ambidentate ligand. Okay, then we have example of this one. Then you have ionization isomerism where you will get different ions on putting or when dissolving in the solution you will get different ions. That is called as ionization isomerism. Similarly, solvent isomerism and coordination isomerism you can explain. So yes, solvent isomerism requires water. You can see here where water molecules you can exchange, and in coordination isomerism 2 different complexes are there and their ligands can be exchanged. Okay, clear? Next we have isomers of CH. This is important example because you have here facial and meridional, right? So if I have CO, okay, I'll do like this. Okay, so now this 3 forms one phase, so you can put NH3 here, NH3 here, and NH3 here. Okay, and Cl. This is what? This is facial. You can see on one face of the tetrahedron, you are octahedral, you are putting the ligands. Now meridional is like this. If I draw like this, so meridional is like this. If you put on one plane, here NH3, here NH3, and here NH3, this one plane, and this is Cl, and Cl. Okay. Next, sorry, this is not required. Okay. Next we have hybridization. This is important question where you have to explain the hybridization of the magnetic property and geometry of a given ligand. Okay, so how will you do it? Just a minute. Okay, so I'll be telling you how to write down. So very simple step you have to follow. First you have to write down the electronic configuration of cobalt 3+. What is it? It is 3D. Cobalt is 3D6, right? So here you have to draw the 3D6, you have to show here. Okay, 1, 2, 3, 4, 5 and 6. Next you will see the ligand NH3. So you have to here you have to write NH3 is a strong field ligand, so pairing of electron takes place. Pairing of electron takes place. Okay. After that you have to again show the electronic configuration. So I have 3D, 4s and 4p. 3D I will draw like this, 1, 2, 3, 4 and 5. Now there is pairing of electrons, so I will do like this, okay. Then I will have 4s and then I have 4p, okay. Now what will happen? This will undergo hybridization, so you can just simply write down DsP2, sorry, DsP3, D2sp3, sorry, D2sp3. So now you have to draw D2sp3 will have 6 ligands, 1, 2, 3, 4, 5, 6, okay. So you can write down D2sp3 hybridization, and here I have NH3, 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 just put the ligands, okay, and their electrons. You can show the ligand electrons in this way, okay. So that's all you have to write down. Next, what you have to write? Hybridization. So here you have to just give this term. Hybridization is D2sp3. Then magnetic property. Magnetic property is, so you can see there is no unpaired electron, so it is a diamagnetic. Then geometry. Geometry, because coordination number is 6, it is octahedron, okay. Now similarly this can be asked for other compounds also, so you have to practice on your own. Which compounds? You have to practice CO, Cl6 3 plus, okay, NiCl4 2 plus and NiCN4 2 plus, okay. So let me just check, x minus 4 is equal to, okay, sorry, this is 2 minus, not 2 plus, 2 minus and 2 minus, okay. For these 3 compounds also you should be knowing how to write. Any 4 of this compound can be asked, okay. Next, applications. Coordination compounds application can be asked. Any 3 application you can remember, like used in purification of water, used in chlorophyll, magnesium, hemoglobin. Then you have used as a catalyst, used in photography, EDTA, lead poisoning, okay, cisplatin. Any 3 uses you should be remembering. Next, synergic bond in metal carbonyl. So there is a metal carbonyl, we have sigma and pi bond, both is there. So you have to mention where this diagram is important and where the sigma pi bond takes place. So there is one metal to carbon to metal bond, okay, that is donated from filled orbital or filled p orbital of carbon to the empty d orbital of metal. You can see sigma bond is formed by the lone pairs of electron on the carbonyl carbon and the vacant orbital of the metal. Now for the pi bond, what happens? You have filled d orbital to empty anti-bonding pi star orbital of the carbonyl, okay. Next, limitations of CFT and limitations of BVT. You should be knowing 2 points. In BVT there is what? Ligands are considered as point charges, but they are actually not. Next, does not take into account the covalent character, and in VVT you have so many limitations. Doesn't explain the magnetic data, doesn't explain the what I can say color compounds, okay, and it's so many assumptions are there. Next important question is your splitting, d orbital splitting. This diagram is very important, and similarly tetrahedral splitting and octahedral splitting. So please prepare this diagram thoroughly, okay. Okay, next we'll go to D and F block. Okay, some very important questions I have taken, but again, as I told you, any one of this chapter you can do, but yes, it will be good if you do both the chapters. So magnetic moment, I'll be telling you one, you can solve all other like that. So you should be knowing the electronic configuration. So let me take you for this one. Titanium 3 plus, scandium titanium. Titanium electronic configuration is 3d2 and 4s2. Titanium 3 plus is having 3d1, means 1 unpaired electron. Magnetic moment formula is root over of n into n plus 1. To substitute the value of n, 1 into 1 plus 1. So that is root over of 2, and that is 1.414. Okay, so like this you can do for all the other questions that is given. Next is very important, interstitial compounds. Okay, so the compounds in which the small atoms like hydrogen, carbon, nitrogen are trapped in the void spaces, that is called interstitial compounds. So what are their properties you should be knowing? The physical and chemical properties are high melting point, chemically inert, and retain the metal conductivity. Okay. Next you have about the catalytic properties. This is very important. Why do they show catalytic properties? Due to the variable oxidation state, large surface area, incompletely filled d orbital, intermediate compounds, and one example of catalyst also you should remember. Next we have mic metal and its composition. So lanthanoid is 95%, and what is the use of mic metal you should be knowing. Okay. After that we have cerium shows +4 oxidation state because it gets a stable electronic configuration. What is the highest oxidation state by actinoids? It is +7. Which two elements shows +7? That is Np and Pu, right? So this is what you should remember. Next, potassium permanganate preparation. This is again very important, must question. So you should be knowing the step 1 and step 2, the preparation, the balancing of equation. I know this requires a lot of time, but yes, you have to memorize it. Okay. And then we have preparation of K2Cr2O7. So step 1, step 2, and step 3 you should remember. Okay. Next, lanthanide contraction, cause and consequences. Okay, so this anything can be asked here. So lanthanide contraction is what? The steady decrease in the size of the atoms. That is called lanthanide contraction. Why it is? What is the cause here? The poor shielding effect of 4f orbitals. Next, two consequences of lanthanide contraction. You can see the basicity decreases from lanthanide to lutetium, and the size is similar for zirconium and hafnium, and that is why it becomes very difficult to separate them. Okay. Next, why the study of actinoids is difficult? Because they are produced in nanograms, their half-life is very short, and they are very rare elements. Okay. Next, two differences between lanthanoids and actinoids. You can write down any two differences, and if the question is like write the 3 characteristics of lanthanoids also, you can write down here. Write down 3 characteristics of actinoids also, you can write down from here. So 3 questions can be done if you remember this one example. Okay. Next, what we have here, yes, this is important question. Why Cr2 plus is reducing and Mn2 plus is oxidizing when both have CD4 configuration? Okay, I want to explain this question. See, Cr2 plus chromium electronic configuration is 3d5 4s1. Cr2 plus is 3d4. Okay, now Cr2 plus is reducing, means what? It will reduce others, itself it will undergo oxidation. Cr3 plus it will come 3d3 configuration, or I can say T2G3 configuration, which is very stable. Now if you talk about Mn plus 3, okay, Mn plus 3 is having also 3d4. It is behaving as an oxidizing agent. Itself it will get reduced to Mn2 plus, which is having 3d5 configuration. Again, this is special because of exactly half filled configuration, right? Now coming to why is the higher oxidation state of metal is exhibited in oxides and fluorides? Because of smaller size and high electronegativity of oxygen and fluorine. Next, which is a best stronger reducing agent, Cr2 plus or Fe2 plus? So stronger reducing agent means they will reduce other, itself it will get oxidized. So Cr2 plus will get oxidized to Cr3 plus, and Fe2 plus will get oxidized to Fe3 plus. This is 3d6 and this is 3d5. Again, this is a stable configuration. But now the question arises, 3d5 is more stable or T2G3 is more stable? So if you have studied the splitting of the d orbitals, right, T2G goes to the lower energy level, so that is why this is more stable, so that is why this is a better reducing agent, Cr2 plus. Okay, so I'll show you how you can write the answer. Yes, this is how you can write down the answers. Okay. Next, why do transition elements exhibit larger enthalpies of atomization? That is because of number of unpaired electrons, and these number of unpaired electrons are involved in metallic bonding. Okay, so intermolecular forces increases. Enthalpy of activation is atomization is maximum in the middle of the transition series. That is because of more number of unpaired electron in the middle of the transition series. In the series of scandium to zinc, the enthalpy of atomization of zinc is the lowest. Then why? Because it has no unpaired electron, no metallic bonding. Enthalpy of atomization is more in 4D and 5D than in 3D. Big reason, again, as the mass increases, the enthalpy of atomization also increases. Okay. Yes. So in 3D and 4D there is stronger metal-metal interaction. Clear? Next, if I see, we'll go to organic section, that is haloalkanes and haloarenes. So the first haloalkanes and haloarenes where you will get questions, let me tell you, you will get one 2-marker question, okay, and you will be getting one 5-marker question, okay. 2-marker question mostly will be name reactions, okay, and 5-marker will be mechanisms, okay, SN1 plus SN2. These are the things. So what all name reactions I have to study in this chapter? I have given you 5 name reactions, sorry 6, that is Schwarz reaction, Finkelstein reaction, Wurtz-Wittig and Sandmeyer reaction. So these are the reactions that you have to do. So this is Schwarz reaction, okay, you can see the answer. Here it is Finkelstein reaction, so I will write a reaction for you. CH3Cl plus NaI in presence of dry acetone will give me CH3I plus NaCl. Okay. Oh, sorry, one second. Now coming to the next one, Wittig reaction, Wurtz-Wittig reaction and sorry, okay. This is Wurtz reaction. Okay, just a minute. Okay, so I have Wurtz reaction, Wittig reaction and Wurtz-Wittig reaction. So the statement is like this, okay. So aryl halides, when it is treated, it is called as Wittig reaction. So you can see like this, you have 2 aryl halides in presence of sodium and ether, you will get diphenyl. Now if I have Wurtz reaction, okay, Wurtz reaction, you can write down the statement like this, but it will be like 2Rx plus Na dry ether, okay, that will be RR. Now if I have Wurtz-Wittig, this is very simple. See, in Wurtz what we have taken? Haloalkanes. In Wittig we have taken haloarenes. In Wurtz-Wittig we will take 1 haloalkane and 1 haloarene. So I can write like this. Oh, sorry, not X, it has to be R. Okay, so this is what you can write down, okay, and here it will be X2, here it will be NaX, okay. So the statement you can change accordingly, and these are the reactions. Next, what do we have? The Sandmeyer reaction. So in Sandmeyer reaction, what happened? Aniline reacts with dilute nitrous acid to form benzene disonium chloride, which reacts with copper chloride or copper bromide to give aryl chloride or aryl bromide. This is Sandmeyer reaction. So you can have like this, NH2, when it is treated with NaNO2, you get benzene disonium chloride, that is N2 plus and Cl minus. Now if you treat it with CuBr, you will get bromobenzene. Clear? You can treat it with CuCl to get chlorobenzene. Now we have next, okay, yes, next we have some complete the following type of question. So you can see KNO2 will add ONO group, so this one will give me CH3ONO, okay. This is very important to remember. Next you have this is your Wurtz-Wittig reaction, not Wurtz-Wittig, sorry, this is your Wittig reaction, you will get biphenyl here. Next what I have, so Seidzeff rule, this can be asked as a question. So what does Seidzeff rule says? During dehydrohallucination, more substituted alkene is formed. Okay, this is the statement. Now you have to also give an example. So let us take, for example, you have taken butane 2-chlorobutane. Example, 2-chlorobutane if you have taken, yes, in presence of alcoholic KOH. So HCl can go from here, HCl can go from here, you will get 2 products. So you can show like this, CH3, CH, this is one product, plus you will also get a product like this. Okay, so which is the major product? This is the major product, so you have to write here major. Okay, so that is your Saitsev rule tells you. Now moving to next question, aryl halides are less reactive towards nucleophilic substitution reaction. For this we have the first thing is your resonance effect, the partial double bond character, and the next one is your sp2 hybridization. Okay. Next I have steps in SN2 mechanism for the conversion of chloromethane to methanol. So yes, if I have, first you should write like this, chloromethane, that is CH3Cl. If I just treat with OH minus, I will get CH3OH. Now how is this reaction mentioned? You can write like this, CH3Cl, OH minus is there, OH minus attacks from the opposite side, we get our transition state here, okay, where I get H, 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 Cl, and after that what will happen? This part will be remaining, this part will go, so I will get like this. Okay, this is your SN2 mechanism. Next I have okay, what are freons and name the poisonous gas? The chlorofluorocarbons are called as, of methane and ethane are called as freons. Next, name the poisonous gas evolved when chlorine is oxidized by air, that is your phosgene or carbonyl chloride. Next, in haloarines, para isomers have higher melting point as compared to ortho and meta. Why? So here you can write down para isomers have symmetrical structure, or you can just write down are symmetrical. Okay, para isomers are symmetrical and hence fit better in the lattice. Okay, clear? Next we have in the order of their boiling point, increasing order. Okay, so you have bromoform, right? More mass is the more boiling point, so I'll just write down like this 1, 2, 3 and 4, okay, so that I can do it quickly, but you have to write the proper words in the exam. Increasing order means lowest to highest, so we will have chloromethane as the lowest, okay, then I have bromomethane, then I have dibromomethane, and then I have bromoform. Okay, in bromoform we have 3 bromine. Next here also I'll do 1, 2 and 3. So you can see here propane and here butane. So definitely butane will be the highest one. Now here this is branched and this is linear. So branched will be least and then linear will be the highest one. Okay. Next, chloroform is stored in dark bottles. That is why, because it gets slowly oxidized and form a poisonous gas, that is phosgene. You can write the reaction as well. Okay. 3 differences between SN1, SN2, you can write down any 2, then any 3, sorry, then you have A and B in the reaction. So what will happen here? This was just Sandmeyer reaction we discussed, right? So A will be what? Here A will be N2 plus NCl minus, and here I can use CuBr. Okay. Next, mechanism for the conversion of 2-bromo 2-methyl propane to 2-methyl propane 2-OL. Which type of solvents are used in this reaction? So this is what? This is your SN1 mechanism, right? So you can write down here SN1 mechanism. Okay, then you write down what is the reaction happening here. 2-bromo 2-methyl propane. So it is like this. One second, here one H will not come. Yes, so it is like this. 2-bromo 2-methyl propane will give me 2-methyl propane 2-OL. Okay, so this reaction, because it is a tertiary halide, reaction undergoes SN1 mechanism. What is step 1 here? Step 1 is formation of carbocation, right? Formation of carbocation. So what will happen here? I can just write down like this: CH3, CCH3, CH3. here I am having Br, this Br goes out, this is a slow step, and I get CH3, CCH3, and here plus. Okay, and step number 2 is what here? Attack of nucleophile. Okay, so I have here CH3, here plus, OH minus will attack here, and I will get okay. This is the first part. Next, what type of solvent is used here? We use polar protic solvent. Clear? Now if I go to next part, that is enantiomers and racemic mixture definition, you can see here. Enantiomers are the stereoisomers with mirror non-superimposable mirror images. Racemic mixture, equimolar mixture of two stereoisomers having net optical rotation as 0. Next we have a question here. Primary alkyl halide C4H9Bra reacted with alcoholic KOH to give you compound B. Okay, so I have A here, C4H9Br. It reacted with alcoholic KOH to give compound B. Okay, now B is reacted to give you compound B, reacted with HBr to give you C, which is an isomer of A. Okay, when A is reacted with sodium metal, it gives you compound D. If it reacts with sodium, it gives you compound D, which is C8H18, which is different from the compound formed when N-butyl bromide is reacted with sodium. Okay, give the structure of A and write all the chemical equations for all the reactions. So if you see, this is C4H9Br. It is not a linear N-bromobutyl, okay, or it is not 1-bromobutane, because if you do 1-bromobutane sodium ether Woods reaction, you will get octane, and it is straightly saying that this is not that compound. So this means definitely this is not 8N-butyl bromide. And we also want a primary, so what other structure I can have for A? So I can write like this as A. Okay, so in this case what I will happen? If I have alcoholic KOH, okay, so if so this is A, CH3, CH3, CH, CH2Br. This is A. Now if you treat it with alcoholic KOH, now this bond will go and I will get CH3, C, CH3 double bond CH2. Now if you again treat with HBr, what will happen? It will follow Markovnikov's rule. Br will be added here, so I will get and Br, right? So this A and C is isomer now. Now if this one is treated with, A is treated with sodium ether, so what will happen? It will undergo Woods reaction. So here it will be like this: CH3, CH3, CH2, CH2, CH3 and CH3. This will be the product that will be formed here. Okay, next okay, just a minute. You can take A as this one also, right? I think 2, 3, 4. Yes, I can have anything. I can have A as this one, or I can have A as this one as well. Okay, both the products are possible. Next question will go to alcohols chapter. Okay, so for the first 2-marker question, so in alcohols also you will expect question 1 2-marker question and 1 5-marker question. Okay, here also you will get 1 2-marker question. So what can be a 2-marker question? First is your preparation from phenol, preparation of phenol from cumin. This is important question. You have to write the definition and then the reaction. Next what I have, that is Williamson ether synthesis. So here also you have to first write down the statement and then you can write down any reaction, like for example CH3 CH2 O minus Na plus CH3Br. Here what will happen? This one will attack here and I will get CH3 CH2 O CH3 plus NaBr. Okay. Next we have this one. If you treat copper at 573 Kelvin, so you will have CH3, C double bond O, CH3, oxidation of OH, and if you have C6OH5, that is phenol with zinc dust, you will get benzene ring. Okay. Next I have identify A and B in the following reaction. So this is what? This is your Coles reaction. So the product here will be OH and COOH, and here I can do, you are treating it with HI. So what will happen? This side tertiary will form. So I will get Ci plus C2H5OH. Okay, so this is your product B. Next I have boiling points are higher, solubility is higher, that is due to hydrogen bonding, right? You can write in full sentence. Lucas reagent, how will you distinguish between primary, secondary and tertiary alcohol? So mixture of anhydrous ZnCl2 and concentrated H2SO4 is called Lucas reagent. Now if you take a tertiary alcohol, right, like this, okay, and if you treat it with this one, that is ZnCl2 plus H2SO4, you will get a compound like this. Okay, and you can find turbidity immediately. Okay, that is the first thing. Next, if I have like this, that is a secondary alcohol, and if you treat with the same reagent, then you will get after turbidity after 5 minutes. But if you have a primary alcohol like this, this is CH2, CH3, CH2, OH, and if you react, then you will find no reaction. Okay, that is how you can distinguish in the Lucas reagent. Next, these are some important terms. Rectified spirit, 95.5% will be ethanol. Absolute alcohol, 100% ethanol. Denaturation of alcohol means adding some compounds like pyridine and copper sulfate to make the alcohol unfit for drinking. Okay. Okay. Next, among orthonitrophenol and phenol, which is having higher pKa value, so you should remember here that higher pKa value means less acidic. So phenol will have higher pKa value. Okay, why? Because it is less acidic. Okay, orthonitrophenol is more acidic. Again, why more acidic? Because it has a electron withdrawing group, which is your NO2 group. Okay, you have to write it in the form of sentence. Next, how do you prepare aspirin from salicylic acid? So please remember, this reaction is important. So you have to take salicylic acid and then treat it with CH3CO whole 2. You will get a replacement here, and then you will get, this is called as your aspirin compound. Next, orthonitrophenol is steam volatile but not paranitrophenol. Explain how to separate them. So here what happens? Orthonitrophenol is steam volatile because of the intermolecular hydrogen bonding. Okay, in intramolecular, whereas in paranitrophenol it is intermolecular hydrogen bonding. How are they separated? Using steam distillation. Next, what I have, yes, Coles reaction. Okay, so you have to write the statement and the reaction. For every name reaction, you have to write always the statement and the reaction in terms of word. Similarly, Riemer-Tiemann reaction, statement and the reaction, this will give you 2 marks. So always mention to write, also always remember to write the first statement and then the reaction, not only reaction or not only statement. Next, when diethyl ether is heated with limited HI, so if I have diethyl ether, it is like this, right? So if I have limited HI, then I will get one side C2H5OH and the other side C2H5I. Now if I have excess HI, then I will get 2 times of C2H5I. Okay. Next, we'll go to 5-marker question. So in this chapter we have 3 mechanisms. What are they? Conversion of alkenes to alcohols, alcohols to alkenes and alcohols to ether. So the first one you can see alcohols to alkenes, the mechanism, and here you have to identify the product. This is important. This is again your, I can say, Coles reaction. So you will get OH here and COOH here. Next here, this also I discussed, it will give you CH, this side I will come, C and I. Okay. Next mechanism, that is first what happens, protonation of alcohol takes place, then formation of carbocation, and then deprotonation takes place to give you alkene. Next what I have here, conversion again. So phenol with bromine, what you will get, 2,4,6 tribromo-phenol. Okay, then phenol with zinc will give you benzene ring. Then C2H5OH plus Na will give you C2H5ONa plus carbon will be H2. How to prepare phenol from aniline? So here I can show you. So if you just take aniline, convert it into benzene disonium chloride and warm it with water, you will get phenol plus N2 plus HCl. Next we have the mechanisms for alcohols to ethers, the second mechanism that I told you. Alcohols to ethers, you should remember, first the step is same, it gets protonated, then alcohol behave as a nucleophile, attack on another nucleophile, and then we get this one, and then after that there is deprotonation to give you the ether. Next, how anisole reacts with acetyl chloride. So they are very simple. So here Friedel-Crafts acylation takes place, and this is an ortho para directing group. So your acyl group will be attached at ortho and para position. Okay, simple and easy. Next, mechanism of alkenes to alcohols. Okay, I will discuss that. Before that, let us see here. Here what happens, first H2 and H plus Markovnikov addition will take place. Here I will get OH and here I will get CH3. CrO3 is an oxidizing agent, so it will convert this to this one. Okay. Next, what is the reaction? Hydration of alkenes to alcohols. So you can see the mechanism here. So first what happens? Carbocation formation takes place, then attack of the nucleophile takes place, and then there is deprotonation. Okay. So these three mechanisms, please remember, it will be asked in the exam. Okay. Next we have an alkene C3H6 reacts with H2 and H plus to give you compound Y. Compound Y further undergoes reaction with CrO3 to give you compound Z. Write the IUPAC name of X, Y and Z. This is very simple question. C3H6, we have propene which is like this. Okay, this is compound X, that is propene. Then reacts with H2O and H plus. Okay, so this one will do what? Alcohols. Addition in Markovnikov's rule, this is Y. After that what happens? Undergo reaction with CrO3 H2SO4, oxidation will take place. So CH3 double bond O, CH3, and this is Z. Okay, IUPAC name for this one, propene. Okay, then you have propane 2OL, and then we have propanone. Clear? Next, which among the following has the lowest and the highest pKa value? Now lowest pKa value will be the one which is highly acidic, that is your para-nitrophenol, because of the presence of electron withdrawing group. And if you see here, ethanol is a, what I'll say, aliphatic alcohol, which is always less acidic than the aromatic alcohols, right? So that is why highest pKa value will be for ethanol, means it is least acidic. Okay, so if I want to order the acidity, so this is 1, this is 2, this will be 3, and this will be 4, highest acidic. Okay. Next, how is phenol prepared from sulfonic acid? Write the equation. Anisole reacts with methyl chloride, effect of electron donating group on acidity of alcohol. Electron donating group decreases the acidity. So first let us see, when benzene is treated with oleum to get sulfonic acid, and then it is treated with NaOH to give you phenol. Next, anisole reacts. So anisole will undergo Friedel-Crafts alkylation to give you ortho and para substituted compounds. Next we'll go to next chapter, that is aldehydes and ketones. So here also some name reactions are there that you should remember. So from this chapter only 5 marker questions will be asked. Okay, so first of all, CH3CHO, its name is your ethanol because we have 2 carbons. This is prop 2ENAL, and then this is I have 1 2 and 1 2, so that is your ethyl ethanoid. Okay, this is your ester group. Next, Gattermann-Koch reaction. So this is for the preparation of your benzaldehyde. So you can see here, when benzene is treated with carbon monoxide in presence of HCl and anhydrous AlCl3 and CuCl to give you benzaldehyde. Next, equations for the reactions between carboxylic acid and PCl5, formaldehyde and concentrated KOH, formation of oxime from carbonyl compound among formic acid and acetic acid, which is more acidic, give reason. Okay, so first of all, with PCl5 you will get RCOCl plus POCl3 plus HCl. Then reaction between formaldehyde and concentrated KOH, that is your what I can say, Cannizzaro reaction. So formaldehyde like this, okay, with concentrated KOH. So this will give you HCOO minus K plus and CH2OH. Then formation of oxime from carbonyl compounds. So oxime is like this. Yes. So what will happen here? Water will be removed and you will get, okay, this is oxime. Okay. Next, which is more acidic? So definitely formic acid is more acidic because its conjugate base is more stable than the acetate ion. Next, what we have, preparation of carboxylic acid from Grignard reagent and HVZ reaction. Okay, so HVZ reaction, one second, yes. So Grignard reagent, how can we prepare? So you have to take Grignard reagent, react with carbon dioxide, and then you have to acidify it to give you carboxylic acid. So the reaction takes place like this. See, if I have any Grignard reagent, RMgX, react with CO2, which is your dry ice, this is minus, this is plus, this will attack here, this one will come here, then I will get RC double bond O, O minus MgX, and then if I do hydrolysis, I will get RCOOH. Okay. Next here, HVZ reaction, when you treat carboxylic acid with alpha hydrogen in chlorine or bromine in presence of small quantity of red phosphorus, you get alpha halo acids. That is your HVZ reaction. Okay. Next, I have general equation involved in the addition of ammonia. So this is your general equation. Explain Cannizzaro reaction with an example. So yes, so this is your, one second. Okay, so this is the answer number C. Okay, why can aromatic aldehydes do not show Fehling solution? Because aromatic aldehydes undergo Cannizzaro reaction. Now what is Cannizzaro reaction? Here I want to explain. So see, aldehydes or ketones without alpha hydrogen undergo disproportionation reaction. Okay, I am writing in short, in presence of concentrated alkali. Okay, this is called as Cannizzaro reaction. Now for example, if I have benzaldehyde, okay, it is not having any alpha hydrogen. If you take concentrated NaOH, so what I will get? COO minus Na plus, and here I will get CH2OH. Clear? Okay. Next, I have here, okay, give the following with respect to the carbonyl compound. So first of all, it is hybridization is sp2, sigma pi bond 3 sigma 1 pi, and the bond angle and geometry is trigonal, planar, and 120 degree. Okay. Next, conversion of toluene by side chain chlorination. So if you take toluene, do side chain chlorination, then treat it with water, you will get benzaldehyde. Okay. Next, what I have here, following transformation: butane 1-OL to butanoic acid, you can use KMnO4. Okay, then cyclohexene to hexane 1,6-dioic acid, again KMnO4. Butanol to butanoic acid, any mild oxidizing agent, you can use Tollens reagent. Okay, next, Clemmensen reduction with example. Yes, so first you have to write the statement and then the reaction. So in Clemmensen reaction, carbonyl groups gets converted to CH2 group. Next we have distinguish between aldehydes and ketones, you can use Tollens test. Complete the following reaction. This is your Friedel-Crafts acylation. So I will get the product like this, COCH3. Then here what will happen? This is oxime formation, so I will get CH3, CH3. Okay, I will write it bigger this side. So what I will get? Yes, CH3, CH3 double bond, not double bond, sorry, here NOH. Okay, this one is your N. That is reaction with ammonia and its derivative. Among 4-nitro and 4-methoxybenzoic acid, which is more acidic? Obviously 4-nitrobenzoic acid, because of the electron withdrawing group. Okay, so you can write down electron withdrawing group is there, so the conjugate base will be more stable. Okay, next we have the structures of X, Y and Z. You have to find out. This is very good question. So first MgBr, there will be what? There will be Grignard reagent formation, and then here there will be, you will have here, this one will attack on COO minus MgBr. Then here hydrolysis, you will get benzoic acid. Okay, next order of their acidity. So here you can see, so I will make it like 1, 2 and 3. So here you see electron withdrawing group is there, so it will be more acidic. Question is asking increasing order, so we should write increasing order. So this one will be least acidic because it is electron donating group, electron withdrawing group. So 3 will be the least one. Then here this is neutral, so this one will come, and after that the most acidic, that is nitrobenzoic acid, because of electron withdrawing group present. Next, what is the haloform reaction? Aldol condensation. Name the product formed when. Yes, so first of all, haloform reaction, you should have a methyl ketone group. It get oxidized to give you chloroform, or you can say haloform, and the a carboxylic acid salt with 1 carbon less. Next, aldol condensation, definition and the reaction you have to write, the statement of aldol condensation and the reaction. So you can study it. I am just telling you the things that you have to remember. Product formed when formaldehyde reacts with Clemmensen reduction. So if you have formaldehyde, it is like this. Clemmensen reduction will do ZnHg HCl, so this one will convert to H2, product will be CH4. Okay, so 1 second, this is wrong. Okay, I'll correct it. This is methanol, CH4. Next, what I have, complete the following reaction. So this one will give you I think ethanoic acid. Okay, I'm writing here only. Then this one will give me CH3COCl, and this one will give me amide. Okay, next the pKa values are given to you. Arrange them in the increasing order. So if you see, the one which is having highest pKa value will be the least one, so that is your acetic acid. Okay, 1 second. Okay, acetic acid, and after that you have this one, that is benzoic acid, and after that we have trifluorobenzoic acid, trifluoroacetic acid. So you can easily counter why this is happening, because of electron withdrawing group present here. Okay, next question will go. Okay, here a small change, this is C8H8O. Okay, an organic compound X with molecular formula C8H8O forms an orange precipitate with 2,4-DNP and gives a yellow precipitate on heating with iodine. It neither reduces Tollens reagent. So this must be a ketone group with C8H8O. The ketone group that I can think of, which is having a methyl ketone as well, because it is reducing I to NaOH. It is reacting with iodine and NaOH. So this is the possible structure. Okay, so this is your X. then what it is doing, it is reacting with 2,4-DNP. So I can react it like this, right? This is 2,4-DNP. So what I will get here, NO2 and NO2, clear, and gives yellow precipitate with iodine. So if you have iodine and NaOH, you will get here COO minus Na plus CHI3. Okay. It neither reduces Tollens reagent, bromine water, no reaction on oxidation with chromic acid, CrO3. So if it is undergoing oxidation, what will happen? This one will get converted to COOH. You can see one carbon less is there, so you will get benzoic acid. XY is your benzoic acid. Okay. Identifying X and Y will give you 1 mark, and writing these 3 reactions will give you 3 marks. Okay. Next, between methanol and ethanol, which would undergo aldol condensation? Obviously ethanol. Why? Because it has alpha hydrogen. How do you convert propanol to propane? Write the reactions. Okay. So this is very simple. First of all, ethanol. Okay. You have to explain why. Because it has alpha hydrogen. Next, you have to write the reaction. So what I will get here? CH3COH in presence of dilute NaOH. What I will get? CH3CH double bond CHCOH. No need to see the mechanism, you just have to write the product. So this will give you 3 marks. How do you convert propanol to propane? Write the reaction. How will you convert? So you can write down by reacting with zinc amalgam, okay, in presence of HCl. What is the reaction here? We have propanol. So CH3COCH3 in presence of zinc HgHCl, that gives me propane. Okay, this is your Clemmensen reduction. You can also write Wolff-Kissner reduction. Next, write the reaction and the name of the products obtained when acetophenone reacts with sodium chloride. Explain the formation of anhydrides from carboxylic acid with an example. So carboxylic acid, if you react with H2SO4 or P2O5, you will get an anhydride. And this one, if I react acetophenone with sodium hypochlorite. So this is your acetophenone, right? And if you treat it with sodium hypochlorite, NaOCl, this bond will break. You will get here COO minus Na plus, and this one will get you CHCl3. Okay. Next we'll go to optional chapters. So I told you, you have to do these many questions for a short 40 plus to 45 plus, and here are some extra chapters that you can do here, that is electrochemistry, biomolecules and amines. Okay. So if you leave aldehydes and ketones, then you have to do these 2 chapters. Okay. Now let us go to the first thing, that is amines. So first one is your preparation of para-hydroxyazobenzene, that is your coupling reaction. Again, statement and reaction you have to write down. Next we have pKb of aniline is more than methanamine. Okay, sorry, one second. Yes, pKb of aniline is more than that of methanamine. This is why? Because in aniline the lone pair of electrons are involved in resonance, and hence it is less available for donation, right? That is the statement here, and you have to write 2 reasons, so you can explain these 2 reasons. Next I have Gabriel phthalimide synthesis. This is important question. Carbyl amine reaction, important question. Order of basicity, important question. Carbyl amine reaction, you can write down aliphatic amines react with chloroform in presence of KOH to give isocyanates which have a foul smell, and this test is used to detect the presence of primary amines. Next, the order of basicity. Okay, so you can see here you have CH3NH2, this will donate better. Then we have NH3, C6H5NH2 because it is a what I can say, aniline, aryl amine, the nitrogen lone pair is involved in resonance, so it is not available for donation, so its basicity is very less. Next, Gabriel phthalimide, you can write the statement and the complete reaction. This itself is a very important question. So if you are studying this chapter, you must do this particular question. After that, we have Hinsberg reagent, again important question. Hofmann bromamide degradation, again important question. So Hinsberg reagent, so first let me discuss what is Hofmann bromamide degradation. Amines on heating with Br2 and aqueous NaOH gives you primary amines. This reaction is called as Hofmann bromamide degradation. Any example you can write down where you can see this CO group will vanish and you will get RNH2. 1 carbon less amine you will get. Now if I see your Hinsberg reagent, so it is benzene sulfonyl chloride. It reacts with primary amines to give you a salt which is soluble. Then secondary amines react to give you a salt which is insoluble, and tertiary amines do not react at all. Okay, next we have an aromatic compound A on treatment with aqueous ammonia and heating forms a compound B, which on heating with Br2 and KOH forms compound C of the molecular formula C6H7N. Write the structure and the IUPAC name of A, B and C. Give reason. During reduction of nitro compound, scrap iron is used. Solubility of aliphatic primary amines decreases with the increase in the molar mass. Okay. So first of all, I will discuss this part, why scrap iron is used. Because in scrap, if you use scrap iron, which is FeCl2 is produced as a product, and this FeCl2 undergo hydrolysis to give you HCl back. Okay, so with a very small amount of HCl, the reaction can take place again. So that is why we can use scrap iron. Next, what happens here? Aliphatic solubility will decrease. Yes, if you increase the mass, the hydrophobic part will increase, so solubility will decrease. Now coming to the first part here. So you have A is an aromatic compound which is on treatment. So I have already discussed this question in the 5 marker video. So I will be telling you like this. This is A. If you treat it with ammonia, you will get this one. Okay, this is B. And if you then treat it with bromine and KOH, you will get aniline. Okay, so these are the structures of A, B and C. Okay, next question here will go for biomolecules. So in biomolecules, what all topics you can study, so that you can at least write the important answers from here. So first is the tertiary structure of protein, major shapes, then reaction of glucose to show 5 OH groups, and zwitterion structure of glycine. So you can see here, first one, tertiary structure is the further folding of your secondary structure. The shapes that it gives you is fibrous and globular. Next we have a reaction which shows that glucose has 5 OH group, that is your reaction with acetic anhydride. It will give you pentaacetate, which shows that there are 5 OH groups. Next, zwitterion of glycine. So if you see, glycine structure is like this, right? Not like this. I have CH, H, COO minus and NH3 plus. Okay, so this is the zwitterion structure of glycine. Okay. Next question is, how is peptide bond formed? How many peptide bonds are present in a pentapeptide? So peptide bond is formed by the reaction of the amine group of one amino acid to the carboxylic acid of another amino acid. Chemically, the peptide linkage is an amide formed between the COH group and the NH2 group. In a pentapeptide, how many peptide bonds will be there? Pentapeptide means 5 amino acid. These 5 amino acids will be connected by 4 peptide bonds. Next, you have structure of maltose. You can see here, name the protein present in hair. It is your keratin, right? Protein present in hair is keratin. Okay, next, what are reducing sugars? Give example. Naturally occurring optically inactive amino acid. Name one vitamin that is stored in liver and adipose tissue. So reducing sugars are those which can reduce your Tollens reagent and Fellings reagent, right? And example, you can write glucose, galactose, fructose, maltose and lactose. Then naturally occurring optically inactive amino acid is again your glycine, and which can be stored in liver and adipose tissue is your fat soluble vitamins like A, D, E and K. Okay. Next, what are anomers? Give an example of keto sugar. 3 limitations of open chain structure. So here sugars which differ in their configuration at C1 position are called as anomers. Example of ketose is your fructose. Open chain structure limitations, it will not react with Skiff test, it does not react with the hydroxylamine, the pentaacetyl derivative, and it exists in alpha and beta form. Okay, 3 limitations you can remember. Harvard structure of lactose, yes, one second, yes, this is important, you can remember. Denaturation of protein is the loss of biological activity, example curding of milk and your coagulation of egg white. Example of water soluble protein. Okay, so here I have made a mistake, it is asking you for protein not vitamin, so you can write here globular proteins. Okay, example of globular protein is your albumin. Okay. Next we have essential amino acids, difference between RNA and DNA. So yes, essential amino acids are those which cannot be synthesized in the human body, right? That is the first thing. Then example you can write lysine, valine and leucine. Difference between DNA and RNA, single stranded, double stranded. And here what type of sugar we use? In case of DNA we use deoxyribose sugar, right? Deoxyribose sugar, and here we use ribose sugar. Okay. Next bases here are A, T, G and C, and here the bases are A, U, G and C. Clear? These are the easy questions that you can study from this particular chapter. Next, oxidoreductase enzyme, those enzymes which catalyze the oxidation reduction reactions. Name the enzyme that catalyzes the hydrolysis of maltose, it is maltase. Give any one natural source of vitamin K, green vegetables. Give reason sucrose is a non-reducing sugar because it does not have free aldehyde group. What is invert sugar? Okay, so you can see all the answers here written. Okay, enzymes which catalyze the oxidation of one substrate with the simultaneous reduction of another substrate are called as oxidoreductase enzymes. The enzyme which catalyze the conversion of maltose to glucose is maltase. Source of vitamin K, green leafy vegetable. Sucrose does not have free aldehyde group and cannot reduce the Tollens reagent and Fellings reagent. Next, give reason. Okay, what is an invert sugar? So I'll explain this one. See, sucrose is a disaccharide and it is dextrorotatory, means it rotates the plane polarized light in clockwise direction. Sucrose is a disaccharide, so if you break sucrose you will get glucose and fructose. Now glucose is dextrorotatory but fructose is levorotatory. So what happens when the sucrose was there? After some time it will break into glucose and fructose. Now because fructose levorotatory is more than the glucose, the solution now will become levorotatory, means it will rotate the plane polarized light in the anti-clockwise direction. So the solution initially was dextrorotatory, after some time it becomes levorotatory, and that is why the sucrose is called as invert sugar. Okay, so you can see here sucrose is dextrorotatory but after hydrolysis gives dextrorotatory glucose and levorotatory fructose. Since the levorotation of fructose is more than the dextrorotation of glucose, the mixture is now levorotatory. Thus hydrolysis of sucrose brings about a change in the sign of rotation from plus to minus, and the product is named as invert sugar. Clear? Okay, next. Yes, storage polysaccharide in plants is your starch. Name the monomer units of starch, alpha D glucose. Types of starch or the components of starch is amylose and amylopectin. There are two differences you can see here. Okay, okay, so these are your disaccharides, their sugars, their monomer units and their linkage. So if you are getting time, do revise this table. It is very important so that you can just quickly remember all the what I'll say, the linkages and the monosaccharide units present in the disaccharides and polysaccharides. Okay, now we will go to the less important chapter, that is your electrochemistry. So here what all things you should be knowing: Faraday's first law and Faraday's second law. Okay, their statement you should be knowing with the formula and the terms of different formula. Faraday's first law says that amount of matter deposited depends on the amount of electricity passed. Second law is about your series connection. If you have two electrodes, you are passing same amount of current, M1 by M2 is equal to E1 by E2. Next, what we need to know, SHE, very important question. So you should be knowing the construction of SHE, that is a normal hydrogen electrode. Working principle is not that important, okay, but yes, construction is very important, and then why platinum platinized is used. Yes, so this is the standard hydrogen electrode construction, working principle, and the diagram. This diagram is very important. If you have time, do study these two diagram and this first part, okay, this first part is very important. Next, H2O2 fuel cell and the cathode and anode reaction. This is also very important question. So you have to draw this very simple diagram, and this reaction you have to remember, okay. Next, we have direct measurement. So this is again a new question, has been asked many times in this year pre-board and in model test papers. So measurement of ionic solutions through Wheatstone bridge is not possible. Give reason. So for that, because direct current can change the composition, and electrolytes, it is not possible to connect the wires to that. So to solve this problem, we can use alternating current, and this electrolyte can be taken in the conductivity cell, which can be connected to the Wheatstone bridge to measure its potential, okay, sorry, conductivity. Next, graph of molar conductivity versus concentration for strong and weak electrolyte, okay. So, okay, sorry, this was the last question I will be discussing here. So, for molar conductivity and root over of concentration, so for strong electrolyte the graph is like this, for weak electrolyte it is like this, okay. So this is like for strong electrolyte, you can write NaOH or just mention as strong and weak electrolyte, okay. So strong electrolyte, okay, and this is weak electrolyte, okay. Next, for the strong electrolytes, write the equation that represent the variation of molar conductivity with dilution, okay. This is lambda m is equal to lambda naught m minus a root over of c. This equation is also called as d by Huckel-Onsager equation, okay. So please remember. So see, these are the numerical questions from electrochemistry. I am not giving you because that may be little difficult, but yes, I will be telling you the formula. This formula you can remember. This question, if it is asked, it is very simple, where E naught will be given, you have to calculate delta G. Apart from this, what you can study if you have time, Kohlrausch's law, okay, Kohlrausch's law. Apart from this, you can study also about rusting of iron. So these are the three topics that you can cover apart from the questions that I have discussed, okay. Yes, so students, the motive of this video was to give you some most important questions. So if you do these many questions, then definitely you can get 40-45 plus in chemistry, which is a decent mark for passing the examination. But again, I am telling, this is not our target. We have to target 70 out of 70. So for that reason, you need to watch all my 1 marker video, 2+3 marker video, and 5 marker video, and numerical videos. And if you are getting time, please watch my Brahmastra series video. I have given you every possible question from a chapter in those videos. Please do watch those videos if you have time, okay. If not, first focus on this PU2 marathon series that we have started. Any other thing you want, any other any other thing that we can do for you, please put down in the comment section. We will definitely address to it. And thank you for watching, and do not forget to subscribe the channel, because many more important and helpful videos will be coming for your preparation for PU2 examination, okay. Thank you and all the very best. Keep studying hard till your exams are over, okay.